Hello, everybody. Welcome back to our usually weekly broadcasts where we're talking about the development updates for Equilibrium. For those who are not as familiar, I just want to mention real quick a few quick disclaimers. Also, I apparently have too much going on at the same time. Okay, now we're good. Quick disclaimer, the discussion today is not a solicitation for an investment and does not construe financial advice. The Quill and corresponding wrapped Quill tokens discussed on this broadcast, as well as any other tokens that may be discussed, are utility tokens, and Equilibrium Inc. does not encourage or endorse engaging in speculation on the utility token of the network. Now, with that out of the way, let's go ahead and get into dev updates. All right. So, for the past 2 weeks, we've been putting a lot of effort into resolving issues around the release of 2.10.18. There's going to be more to come about that. I should mention real quick a couple of things that we do mention in every broadcast. The mission of Equilibrium is to secure every bit of traffic on the internet, whether Q-native, other decentralized protocols, or the broader web itself. The ways we do this are through native secure applications and development tools, API-compatible tooling like you'll see today, and enhancing the privacy of other protocols. Now, back to 2.10.18. There's one outstanding blocker, and it relates to synchronization in kind of a subtle way. It's specifically getting the trees to align properly. The native hypergraph store of the network has essentially some underlying trees that provide a CRDT-style primitive for the vertexes and the hyperedges of the hypergraph. And one of the things that we've been finding is there's some issues around the synchronization of this data. And it really comes down to the way in which we're surfacing this information back from the syncing side, like the client side that's requesting the data, and the server side that's providing it. We're narrowing it down further with every single update that we've done to this branch, and the most recent update includes a little bit more extra debug details that will allow us to get this over the finish line. You can also see, compared to the previous broadcast, that shard coverage is increasing still, halt risk is decreasing, and of course the needs coverage section has also decreased. So things are moving, but we need to get this release out, and there's one blocker left in that. I know that there's some folks that may have some questions around that. Feel free to drop them in on Twitch or on Twitter. I'll be happy to respond to either, although admittedly I don't get a chance to see all the questions as they pop up, so I'll be going back and forth a bit. Other quick updates. QNS. So we're going to be shipping an update to QNS somewhere between the next 24 to 48 hours. It'll include improvements to the auctions and offers features, provide deeper integration with Quorum Mobile, which you'll see through an update to Quorum Mobile itself, and also add the ability to message the owner of a particular name using our underlying dispatch primitive that is what powers Quorum itself. Quorum Mobile itself will also be getting an update with more L1 supported on the wallet, including Monero and Zcash, and we'll start to include that deeper integration with QNS, supporting all of the full QNS features as they exist today. Other than that, some very important things as we get closer to launching on the app stores directly, faster sync and on-device full sync. One of the things that some people aren't familiar with if they haven't dived into the source code is how we surface information between different instances of Quorum. So if you're using Quorum on web and you authenticated Quorum on mobile from web, there's some things that exist on the web app that don't exist on the mobile app, not just in terms of features, but also the messages that you previously had. And so one of the things we're updating around synchronization is support to fully sync this data over if you choose to do so. There's obviously, certain caveats to that, and some users would like to be more able to make a decision on what kind of data they want to sync, whether it's just preferences and profile information, or if they want to sync their full chat history. Like I said, there's trade-offs in that. And so users will be given the option to choose which degree of synchronization they want, but that is at least something that we're going to add for users that really want to have their full chat history. Alongside that, we'll also have some bug fixes for some quality of life issues that people have been reporting in on the beta. And thank you very much for all the bug reports. Really appreciate it, and it helps make the app a lot better as we get closer to the App Store launch. Okay, I just got a question from Black Swan. Are we sure that all possible variations of frame production issues have been resolved? While we haven't had frame production incidents for a while, it would be great to be sure this topic is fully closed. Yes, so on the frame production front, there were a couple of different issues. To summarize, I would put it into one of three categories. The first category would be that there was one archive node that was, as part of the consensus loop, that had went offline. One of the people running the archive nodes decided that they were no longer going to run an archive node. Another individual has stepped up, and we have since brought it into the fold. That's one of the things that came into play. We have a roughly 2 of 3 consensus, and there's 6 archive nodes total. And so when we were having some issues around stability of the nodes themselves, we essentially ended up in a situation where we had 4 active nodes because one went offline due to the user choosing to do so, and then another that was offline due to a bug. And so by consequence, it was a pretty slightly unstable situation. Anytime there was an update that went out, if there was an issue with the update, we do have a rollout by canary, so one node is targeted first. But that doesn't change the dynamics at all. It just means that given that it's 2/3 consensus, you could be in the situation where 3 of 6 nodes were effectively working, meaning that the network would halt for frame production. That is now resolved. So that is one of the things that is done to resolve the frame production issue. The second was there were some subtle changes we were making around consensus logic for a bit there, and that also was something that we would, find halt conditions and have to overcome them, and that was just another one of the things that could induce a network halt. The third thing was synchronization related issues themselves, where the synchronization was causing the participants in consensus to disagree on the state of the network moving forward. And this is one of the reasons, for example, why we haven't launched QClient yet, is because we've been slightly altering some of the protobuf messages that are used on the network. And so by consequence, that means that in that scenario, you have some messages that include things that a QClient would be wanting to interact with. And so by not releasing QClient, it means we won't have to deal with support issues. But because those things are changing, that could also lead to consensus halts. All of those 3 categories are now completely out on the wayside. The only thing left that we're trying to deal with now is just strictly sync related. Okay, so next up, we're going to be talking about the services that are launching on the network basically in a couple hours once the billing tests that have been in flight are done. Oh, okay. Do we feel that archive nodes aligning on the expected root challenge is solved? So that's actually what's going to be coming out in the next update to the .18 branch, is resolving that particular issue. The logs that we've been getting back, including the latest ones that were added in the latest commit on that branch, are giving us greater detail and insight about where these differences are happening, and effectively can give us enough information to understand why those differences are happening. And that'll enable us to actually get over that hump and get 2.10.18 out the door. Yeah, so QStorage. If you were here for the previous dev talk, then you've already seen this slide. You know what's in the box and what's not in the box. And effectively, you can just divide it into things that don't require interactions with other services that we might not have yet, or interactions with services that we have that we'll never have, things like, for example, we're never going to have intelligent tiering. We don't need it. It's basically the network is an edgeless network. We don't have to worry about Glacier versus edge deployments. The other thing, this is actually slightly out of date. I did just copy this slide from the previous talk, so I actually want to mention real quick that event notifications actually is included, and I'll get to why in just a second. Also, QKMS will be part of this, supporting symmetric, asymmetric RSA, asymmetric elliptic curve cryptography, including a couple of extra curve types that I'll be demonstrating, HMAC, SM2, which is for the Chinese audience, and then, of course, integration with QStorage itself. And we'll also talk about how that works and the permissioning involved. But alongside that is 2 other services that we weren't necessarily sure we'd be able to deploy right away. But because I have kind of an ADHD development style, I was able to actually get these over the finish line so that we could actually launch these in the same time. So that includes QQ, which is our SQS-style service. It provides pretty much 100% API compatibility. There's a few tiny things that we don't do, and it's related to the architectural differences between Q and AWS. But basically, for the majority of all use cases of SQS, unless you're doing something incredibly bespoke, we support all your use cases. Do we need the token primitive working before this can be used, or free version limits until that happens? I'll actually get into that. We'll talk about that in a sec. The other service is QPing, which is our SNS style service. Now, we have a lot of different different actions you can do on QPing that are SNS compatible. There is one additional thing I want to mention real quick, though, of course. There are things that we will not do. We're not going to support SMS compatibility. That is going to be something that will require a little bit of engineering use for somebody who wants to use SNS for that purpose. If you want to do like a Twilio integration with QPing, it's possible. You can do that via our webhook support, but we're not actually going to be doing SMS integration. And I think that for most people who understand the nature of decentralized networks and the ways in which they get used and sometimes abused, you can understand why. Same thing with email. Will Quorum use QPing? I'll actually get to that in a sec. Okay, and then the last thing I want to mention that will also be demonstrated today is Quark, and that is our SDK supporting integration with QStorage and token primitives to allow access to 3D assets that are schema-bound for basically like any avatars, any worlds, any kind of like objects that you interact with that have animations, following a couple of different standards, including FBX. These things plug into Unity, Unreal, Firefox, and Godot, or Godot. I always get them mixed up. But anyway, we're going to be launching our SDK along with these, and we're also going to do a demonstration of Quark near the end. And then, of course, QConsole itself. So, like I said, in a few hours when these billing tests complete, if there's no issues with the billing test that we need to resolve, then we'll be able to launch all of these services and you'll have access to them free and clear. So let's get to that because that's actually going to be the bulk of this talk today. So here I have QConsole. I've already logged in. Now, I want to show the onboarding flow real quick because there's going to be people who we'll need that extra walkthrough and understand how to actually do this. Oh, I see there's another question. Have we had a chance to validate whether someone running an archive node autonomously adds that node to the provers, or does the latter require some explicit network action? At the moment, yes, it requires explicit network action in the form of an update. That is something that will change once we have gotten through the shard out process. But in this current iteration of versions, that's how it currently works. There's obviously good reasons for that, given we've had challenges with consensus just getting to this point. But now that we're at the point that this is resolving, we'll be able to move into a world where we actually don't even need the archive nodes. So I'm going to pop open a incognito tab so you can see basically an unauthenticated context and what that looks like. And I'm going to switch over here real quick to my wallet, and we're going to do a quick login via that. And so onboarding onto QConsole is pretty straightforward, but I'm going to demonstrate what that's actually like when you're using Quorum. But we'll do the regular wallet approach first. So you choose your wallet, of course, and then you authenticate with that, and then you connect, and then it's happy and everything is good. You create a we'll go ahead and create a new account. I don't think I've created one with this wallet yet, so if I did, it'll fail, but we'll find out. Nope. Okay. So now I get a signature request to actually sign. Let me get that. There we go. Oh, see, yeah, okay. So let's go ahead and hit try again. We're going to go back through that process, but instead sign in. It is effectively the same. The outcome's the same. Rainbow's giving me grief. One sec. This is the other thing that if anybody's done any crypto development in like the traditional Web3 context, holy crap, is Wallet Connect busted. Would love to fix that someday. Okay, so now we're logged into QConsole and you'll have access to all of your resources. There are no current assets, and the reason is because when you create a new account, it is pending approval. And the reason we're doing that is to basically, one, limit the onboarding rate, because there's going to be people who will want to onboard rather quickly. And obviously, every new user that's onboarded is going to create a degree of support that we may need to assist with. And on top of it, we also need to have a degree of quality control with respect to users onboarding, because if anybody's ever run an open file server, you will know how quickly that gets abused. And so we do have a small onboarding process around this, but it is a necessary evil in order to make sure that we are providing the degree of quality that users expect out of a production web hosting service. So let me go ahead and pop back over here and see if I can get back into the chat. Cool, back in. All right. So that's the onboarding process. There is a pending approval. There's ways to immediately get out of pending approval, one of which is to set up a payment method. The other is to start with what are essentially credits. And so if we go over into the payment section, you can either set up a card payment using traditional fiat, or you can pay with cryptocurrency. And when you view the payment address, you will get a nice little QR code that you can scan and send a payment to. And when you do, the payment tracking back on the back end will pick up on that and then basically allow you to move forward. So let's go ahead and close this, and we'll be back on this already authenticated account. So I already have a bucket set up, and the reason for that is because of Quark, but the way that we do our UI for QConsole with respect to QStorage is we want to make it possible for a user to essentially, in the least number of clicks, deploy a website. And so in order to do that, there's, again, this is an S3 compatible API. So if you have all the tooling set through any of your particular deployment automation tools, they're already compatible. You just need to have an API key and the access key and secret key. And I'll show you how to get that in a second. But alongside that, if you're just wanting to use the UI experience and you just want to launch a static page, the easiest thing you can do is click select folder, and then it will pop open the file explorer. You'll be able to add one single folder, and it just uploads all of them in one shot. Depending on your browser, you might get a, if it's Chrome, for example, if you're sending a lot of files, it will ask you first if you actually want to do that. But anyway, that's basically it. And then when you set public bucket, that makes it accessible at that endpoint with no need for signed URLs. And then if you hit website disabled, it'll tack it over to website enabled, and it'll let you choose your index URL and your 404 URL, which are very helpful things to set if you're running a static page. Okay, and so let me get over to QKMS real quick. So QKMS is surprisingly one of the most important services out of all of these, and the reason is because it basically touches everything. Sign in, offload site ideas from Brain, deploy. I think that's 2 clicks. Yeah, I mean, obviously, you yourself in your web development process, you're going to have your own number of clicks. I'm just saying from QConsole, you should be able to upload a site and have it up and running and accessible within 2 clicks. That's the degree of friction I think should be the case for a website developer. That's just doing a standard web deploy. Anything else is too high friction and unreasonable. There's no reason that needs to be so complex. So as I was saying with QKMS, what's important to understand about QKMS is that while it is a KMS API compatible service, this is a very stark demonstration of how MPC works in Equilibrium. And so how this effectively works is, again, you have access to create keys, which is, key management service. You can choose between encrypt, decrypt purposes, sign or verify, or generate and verify machine authentication codes. And the purpose of those, obviously, is going to be, fit for whatever you need to do with them. But what's important is, again, this is all MPC. So every single key that you're generating, now the UI makes it simple in the sense that you're getting just a standard 2 of 2, but on the actual API calls and subsequent upgrades to the QConsole UI so you can have such flexibility, it's actually threshold. You can choose how this is configured. So, for example, say that you're creating a, multi-party Ethereum wallet. So you would choose SecP256K1, which is the Ethereum and Bitcoin curve. And then in the case of the API call, you would specify what your threshold is. So in other words, if you need 3 of 5 users to sign in order for a message to be signed, then that is how you would configure it. By default here, though, it's 2 of 2. And so the way this works is that on the Equilibrium network side, one of the key shares lives on network. The other key share lives with the end user that is running the QKMS sidecar, basically. Now, there's a couple of different ways in which this sidecar runs. So in other words, a deployment style for server-side wallets. Like one of the things that I guess I could describe it this way. Say that you're creating another Farcaster compatible app, and you want to manage the signing keys on behalf of your users. Not the wallet keys that live in their phone, but the ED25519 keys. One of the cases would be a server-side key management, where you have one key shard that lives with your sidecar and one that lives with Equilibrium. This effectively creates a scenario where you no longer have the same kind of custody issues. So one of the things I can get back to is SecP256K1. And my experience in building multi-party wallets, even back at Coinbase, one of the things that's really, really, really critical and this, I cannot express this enough. In fact, I practically mention it every time I talk about QKMS, is the fact that when you're doing multi-party wallets, and the multi-party wallets that you can find as a service today, I'm not going to name them because I don't want to necessarily drag them for it, but practically any consumer-facing multi-party wallet as a service offering is not doing real MPC. And what I mean by that is that what they're doing is they're splitting the key into multiple shares. Sometimes the key is generated locally on the device. Sometimes it's generated on one of their servers inside a trusted execution environment. But at the end of the day, usually it's just one actual machine somewhere that has the full key, splits it out with Shamir splits, and then the device gets one, they get one, and then there's maybe a third recovery shard somewhere else. And then when they do signing, and this is the really important part that makes this what I basically call not real MPC, is that when they do the signing, they are actually combining the key shares, into one place. So in other words, one of them, again, not going to name names, but one of them does the recombination on the user's device. So at that time, in memory on the user's device is the full wallet key. Or sometimes there's offerings where it's server-side, where the key material goes from the user's device to a trusted enclave on behalf of that user, run by whoever that wallet as a service company is. And it then lives in memory in that trusted enclave. And again, recombined in one place, does the signing operation, and then discards that data from memory. Here's the problem. And this is literally like a multi-million-dollar problem that these companies are going to face at some point when the New York Department of Financial Services, who really understands MPC and knows that that is not real MPC, knows that that is actually custodian behavior, is that because that key material lives in place at one time somewhere, wherever that's held, that's the custodian. And so by consequence, if they're not complying with the custodial obligations that are set in the laws of whichever regions have that requirement, like the state of New York, they are in violation of the law. The reason a lot of these companies have gotten away with it for so long is explicitly because MPC is pretty hard to understand and they're not large enough to be a target yet. NYDFS, though, doesn't really care. Once they figure it out, they're on you. And so the really cool thing about the way that we do MPC, the way that MPC works on Equilibrium, is that it's true MPC. The key shards never live in the same place. So I'm going to demonstrate this, and ironically locally, yes, because the service is running locally and the sidecar is running locally. In this case, yes, this demonstration, the keys are on the same machine. But the way we use MPC is through special threshold signing algorithms. So for example, with SecP256K1, we use a standard ECDSA algorithm for multi-party signing. If it's 2 of 2, like in this case, we use DKLS18. If you're using a higher threshold configuration, like 3 of 5 or whatever, then we upgrade to a different version of DKLS that supports that more complex threshold-based signing. But at the end of the day, the key shards, when they are generated, like right here, they never live in one true place. So I'm going to demo that. And so I'm clicking create, and this is basically the user experience. You click create a key, great. Now let's go over here. You can see the server side where it's saying that it's created an MPC key generation task. It's got 6 rounds of the DKLS algorithm. And then on the sidecar side, you can see that it's picked up on the create key round, is performing DKLS 18, is going through the key generation steps. Now, the first thing that most people would probably react with is, wow, this is kind of slow. And the answer is, yes, it's slow for demonstration purposes. The refresh rate of this sidecar is configurable. I have it currently set to run 1 round per second. So generating one of these keys, once it's picked up on the task, takes about 6 seconds. And so once it's done, then we'll see the key created. But again, like I said, configurable. Your refresh rate can be much, much faster than this. An actual DKLS 18 run under normal network conditions is approximately half a second. So now we've created the key. Now we have a public key. But what's important is, again, the key material lives in 2 separate places. Now again, this is one system, but still, that sidecar holds on to its key share. The service holds on to its key share. And under these 2 interactions, the next thing that happens when you're trying to sign some message, instead of recombining those key shares, it's actually doing an MPC algorithm that's basically it's a form of oblivious transfer that turns kind of like a little multiplication matrix gadget. So if you're familiar with like the, grade school level multiplication where you're writing the numbers out and then you do the like 1-by-1 multiplication steps, it's basically doing the same thing but in binary. And the way that it's doing it is through oblivious transfer, which is proper MPC rather than some kind of like, I don't know, just the farce of like having a trusted execution environment where you're recombining the key and signing just with a regular signing algorithm. So I'm going to hit sign, and then through that process, it's going to actually pick up on the task in a few moments. And when it picks up on the task, it will then proceed to do the rounds of DKLS 18. And so you can see that the signature process, it's technically 2 rounds, but I have the round numbers doubled. So you'll see that like it goes from 0 to 2, and that's because there's alternating steps on each side. And so once that's done, which as you can see it was pretty quick, it generates the assigned output. And of course you can verify it and the signature is valid, and it's a valid signature for that public key that is here. And through that process, no key material has ever been exchanged between these two parties. It is strictly a multi-party computation. And that's very powerful. This basically de-risks an entire industry. Now, let's get to some of the other things. So like I said, for things like Edwards curve for ED25519 with Solana, Farcaster, and so many other networks, this is the same process. You can choose your threshold. You can perform signatures. In this case, it's doing a 3-round algorithm called Frost. And the way that that works is basically the same thing as DKLS, but it's just different algorithm for a different curve for a different signing algorithm. So let's dive into some of the other more interesting things. For example, Quilibrium uses decaf 448 for stealth signing. And so same thing, you can create a decaf 448 key. Or say that you have a validator. Now, say that you have a fleet of validators, like say you're running a mining pool basically. And one of the trust issues that happens with people who run mining pools traditionally, like Bitcoin mining pools for example, is that you're having to depend on the integrity and honesty of that mining pool operator to properly dole out rewards. Now, some blockchains like Bitcoin, they're public. You can see exactly how much has been earned by those miners in that particular pool. So you can kind of hold them to account. But what about a network where that's not necessarily always true? In that case, you need something with a little bit more integrity about the movement of that currency that has been earned. And so one of the things that we support outright is the BLS 48581 curve. That is the curve that validators on our network use in order to authenticate the minting out of coin. So say that you have a collective of like 10 people that are running their own nodes contributing to a single mining pool for whatever reason. And say that you want to ensure that maybe all 10 of 10 has to agree to mint out, or maybe just a threshold like 6 of 10 or 7 of 10. That's all configurable. And then through the use of these QKMS API calls, which by the way are embedded into QClient. So if you want to use any of these like AWS-style APIs, you can actually use them through the AWS tools, but you can also use them with QClient that has very similar call structures. So anyway, if you wanted to mint out, you can't just like single-handedly as the one operating that pool, you can't just mint it out. You have to have the full threshold number of signers participate. And so that's a powerful primitive, and it plays out in so many other ways, and that you'll see later on. The last thing I want to mention real quick, because it's kind of cool, like I think it's just kind of like an Ouroboros effect where it's just eating itself. If you know how AWS API calls work, you know that they're authenticated through HMAC SHA 256 signatures. And sure enough, we have HMAC SHA 256 as a supported key type. So this is another 2 of 2 setup. We're going to just create a simple machine authentication code. We'll hit generate, and the same thing happens, except this time we're doing the raw compute primitive. This is the raw compute primitive of Q. And so it's creating the MPC machine authentication code generation task. It proceeds to kick that off. You'll see it picking up over here. Remember that the way that these calls work is the server side is the evaluator, the client side is the garbler in a garbled circuit production process. And it proceeds to both parties validate the authenticity of the circuit because they both are agreeing to the same code, and then proceed to actually perform the generation process of that machine authentication code. And as you can see here, we have that. Now, verification for machine authentication codes uses a symmetric key. So that means that both parties have to, again, participate to validate a HMAC. And so we'll go ahead and walk through that process. It's going to generate roughly the same circuit. And then as it completes, we will see the machine authentication code is valid. What's the final prerequisite for the Q client release? That would be 2.10.18 being released. As long as there is literally zero chance of any more protobuf changes, that is the time at which we'll release it. It's literally contingent on that. And the only reason why I'm being so strict about that is specifically because in the 2.0 days, we did generate the Q client early on, and people would not necessarily update that in the same degree or frequency that was done for the node software itself. And so there were many times where I had to play support, and the users didn't necessarily know what version of QClient they were running, and ended up resulting in a lot of wasted time providing support when it turned out they just had the wrong version. And so that's kind of one of the things that's really important. Where can we configure shared key thresholds? So like I said, the UI doesn't have that exposed visually, and it won't be that hard to add. It just doesn't have it there. From the API calls themselves through QClient, you're actually able to pass in the threshold parameters. So like in this case, these are just talking about a key that already exists, but when you're interacting with it, and you'll be able to see it in the help information on QClient itself, that'll let you pick out your threshold parameters. And they're pretty flexible. There's some gotchas with some of the algorithms. Keep in mind, some algorithms have logarithmic growth by the set size of the threshold and the total number. Some have constant. A good example of that is for decaf 448. That's actually pretty constant in terms of set size. The only thing you have to worry about is the number of parties that you're collecting the shares from, but that's a human potentially constraint rather than a algorithmic constraint. Let's see. And so, oh yeah, I guess one thing I also want to mention real quick is I didn't talk about it just yet, but for symmetric key usage for encryption and decryption, or asymmetric using RSA OAEP for encryption, you have full support of the entire KMS API feature set. So you should be able to access standard AES 256 GCM as well as the RSA options. One thing I am going to say real quick, we don't have it exposed right now, largely because nobody's going to really use it. It's just not very common. We do have threshold signing support for the NIST P256 curve as well as P384 and P512, but they're just not exposed here because it's just not something that's going to get used very often. Cool. So regarding authentication, though, when it comes to actually deploying applications, speaking in the traditional Web 2 context, say you're a web developer and you have a bunch of different microservices that you've got plugged into various things, and you need to follow the policy or at least the philosophy of the principle of least privilege. And so if you are familiar with the way that it's done on AWS, of course, you would use IAM, you would set up a policy. And if you've ever had to actually create a policy by hand on AWS, you know that it's just a massive pain. We have a at least slightly better policy editor where you can add statements, and it lets you pick from things that obviously services that are available and actions that are possible. But more specifically, it also lets you choose from your existing resources, so you don't have to go dig up which bucket which bucket names you have and everything. It's just slightly nicer. And yeah, it's just a standard AWS policy doc, so you'll feel right at home if you're familiar with any of those. But that said, I'm not a big fan of having to write these policies out manually or even do the visual editing. So in any place where it's possible to make it easier for users to do this stuff, I basically make it possible for you to do it more easily. But I do want to demonstrate real quick, setting up a sample user. It lets you have access to create access keys. Obviously, like I said on Discord, I am not going to demo a production environment, so sorry. These access keys won't do you anything good in prod. But access key management works the same way. API compatibility with all IAM tooling. If you use the AWS CLI, you literally can point the endpoint over to the QNS version, the QConsole version, and it will work. And then the other two real quick. So our message queue service, QQ, you have the choice between first in, first out queues, or just the regular queues that don't guarantee in-order delivery. There's also some like easy to use tools for sending out simple messages, receiving the messages that exist, and then obviously basic permissions. So like I said earlier, I'm not a big fan of having to manually create policy documents, and this makes it easier for you to do so. But taking it one step further, if you go over to QPing and you're wanting to set up your SNS-style notification topic, you can do so, and when you do so, you can add a subscription, and you can see that there's both HTTPS support for webhooks as well as SQS. And the one thing that I don't have listed here, but will be going out in this release, is support for Hypersnap integration. There's some caveats to that, and that's why it's not showing here, but we do support integration flow with services that AWS doesn't even have. So if you're wanting to do like a more in-depth integration with the Farcaster ecosystem, Hypersnap support is just as like first class in support, as well as all the other traditional AWS style services. So add the SQS queue, hit add, it'll tell you that you need to have a queue policy required, and apparently I test more often in dark mode, so I need to add a background for this button. Hey, finally had a demo quirk. Create that permission, and then we can go ahead and test. And when you do that, you will go over to the queue, and you can see it already has a message, and you can go ahead and receive the message, and of course you will have the SNS formatted message. And you can also, again, if you're familiar with the behaviors of SQS, you have to actually delete the messages. And that's basically it. For billing purposes, you can get your current spend, your free tier usage, how you've exceeded over the free tier, the current estimated costs of your spend, and it is constantly live. So every single action you do, you can see your billing as it happens. It's not one of those things that requires a periodic scrape like it does on AWS. You will see your exact spend. The other thing is that it also will try to project your cost based on your usage. It's never going to be perfect. There's no way to have perfect projection unless you are that consistent with your usage, but it is at least helpful to know. And you can see your usage across all the service tiers. And then, of course, you can see your transactions if you use the credit-based billing invoices as they appear, set up your payment methods as I previously described. And that's basically it for QConsole. It's trying to basically provide the entire common plumbing of internet services, but do it in a way that lives on Q as well as provides privacy and secrecy to the users. As you can see, I didn't collect any contact information. At best, I ask for an optional email, which is important if you're using a credit card. But if you don't want to provide that and you're using cryptocurrency, you're free to do so. Okay, and then let's get into the last piece. Actually, let me check real quick because I have Twitch pulled up, but I didn't have Twitter pulled up. Make sure that I have anything over here. Cool. Does Twitter actually show the live chat? Oh, okay, it does. Cool. Hello, Elmo. All right, so let's get into the last part of the deeper integration. So like I said, all these things relate to actual primitives on Q itself. So QStorage uses the hypergraph. QKMS uses the compute primitive. Identity and authorization uses the hypergraph as well as some degree of MPC through the compute primitive. QQ, hypergraph, and also the dispatch mechanism. QPing, dispatch mechanism. All of these things are composable primitives that can create just traditional web services. But let's talk about what happens when you take it one degree further. What if you were to compose the token primitive with the storage service, and you were to create tokenizable assets that are compliant with the RDF schema validation to enforce certain types of 3D assets in this case. And that is what leads to Quark. Now this is going to be lame. I'm going to tell you this right now. I am not a 3D artist. I literally picked up some free art, so just bear with how bad it looks. This is just an example that is rendering raw files. There's no special lighting. It's real lame. But if you are good at game development, which I am not, then you're actually able to plug into this ecosystem rather easily. So we have basically your basic asset that I have as default. And if you check the shop, you'll see that there's no avatars. And you'll also see the wallets integrated, including basically a primitive, like, if you've played any Epic games, you're familiar with like V-Bucks, but it's something kind of like that, but it lives on the Q network. So I'm going to go ahead and close this out real quick. So obviously you could see that there was nothing in the store. Okay, so let's go ahead and come back over to here into QStorage. You can see that I have some world assets there, and that's what was able to load those worlds that were, or at least one of the worlds that was present. I didn't thumb through them. And let's go ahead and select this avatars folder. And it's got some standard VRM assets. They're really bad. I mean, no discredit to the people that made them, but like, I'm not trying to demonstrate the graphical rendering prowess. I'm just trying to demonstrate how the Quark SDK works. So we're going to go ahead and upload. See what I was talking about? It'll ask you. And then you go ahead, upload it. It ends up in the avatars folder. And then when it's done, you will see all of those files there. And as we start, we will pop back in. And you can see that now there's those avatars in the shop, and they are living as assets on Q. And so from here, let's take a look at this pirate model. Okay, so it costs 100 of these Q bucks. So we'll go ahead and buy it. And when you look at your items, you can see the asset that you own. You can set it as your avatar. And when you pop back in, of course, because this is just a very basic game demonstration, and I'm very bad at UI on these things, so just bear with me. You can see that you are now as that asset that you own. This is important to consider when you're talking about decentralized ecosystems. Say, for example, there's quite a few people that I know that play VR chat. And while I have talked to the VR chat dev team, they do not like crypto. They're practically like hysterical in reaction to any proposition of crypto. There is something to think about that I don't think they're quite considering. When you have a user that is playing a game, and depending on the game itself, there's certain things that you might own, like things that you bought from the store, or the game itself. If you've bought the game, all those things is say that it was like, you know, Ethereum aligned, and you're doing this through your Ethereum wallet. All of those things that you own are publicly attached to your wallet address, and unless you have some kind of like, you know, wallet hygiene where you use several different addresses for managing your funds, you're effectively creating the scenario where you're telling the world what games you're playing, potentially when you're playing them, and what assets you have on it, or potentially what worlds you have access to. Now, some people are fine with that. Some people think that that's a massive privacy violation. And so the really cool thing that is a compounding benefit of these different intrinsics that exist in Q is that all of that information is up to you to disclose. So when you go into the shop and you have your wallet, that wallet is a view and spend key that is visible to you, not to the game. That is something that you are using to look up the items that you own. And when you buy one of those avatars, for example, you're constructing a private mint transaction that is minting out that one item. But where it goes to is nobody's business, and it's not visible to anyone else but yourself. And so by that, you're able to, you know, maintain and organize all the assets that you own, and no one else is the wiser unless you choose to show that to somebody. So is this demonstration showing a game? Yeah, it's not a very good one. That is pulling assets from your QStorage using the Quark SDK. Yes, and so like I was saying, the Quark SDK will be published with the rest of this. This demonstration game, which will be published as well, it's just it's a simple demo through Fireox, is actually doing those interactions through QStorage, through the collectible token. as somebody would very quickly guess, how is this working with the collectible token if the Quill token itself is still in the process of shard out? It's because this is right here is one, it's a development environment, and two, it's because it's using an alt fee basis app shard. So it's not beholden to the same rules as the rest of the network, and that's how those alt fee basis app shards work. But in the case of a deployment onto mainnet with this, that's your choice. If you want to have your own logic for for the ledger-like behaviors of a token, if you want to do that, that's fine, and we're completely compatible with it if you have the regular token primitives being used. But otherwise, if you just want to do it on mainnet itself, then you're free to do so. But yeah, it's pretty simple. The actual plug-in points are, like I said, very small. So if I go to like QStorage client, for example, the game ownership manager has a connection to storage. It will proceed to fetch those items. It uses the access key and secret key that is set up with access to that bucket. In this case, I'm just using the root user access key and secret key. That's insane. In a real world context, it depends. If you're wanting to make it such that a user can only access an asset based on what they have access rights to, then you would potentially be custom writing policies for the specific objects that live in a bucket, or you would potentially be doing something a little bit more involved with QKMS, where you would create an HMAC key where you're one of the signing counterparties that is essentially checking and validating that user has the rights to even see that particular access. And so it generates the QStorage given signed URL for it to download the file. But yeah, that's basically it. These are the primitives that I believe will be powering the web as we move forward, but more than that, it gives some privacy back to users in ways that most people didn't think was going to be possible when you're using the old SDKs of the world. And that's kind of the beauty of MPC, is that it enables a lot of things that you wouldn't expect to be turned into a private version implicitly. And the code in which you use to integrate with it is stuff you already know. And so that's very powerful to me. And so, as I said, in the next 24 hours or so, it'll probably be sooner. Billing service tests should be done pretty soon. We'll be releasing QConsole out to the public with all of the services attached, including the Quark SDK. Alongside that, we'll also be rolling out the update to QNS, to Quorum Mobile. Like I said, QNS is about 24 to 48 hours away, and then Quorum Mobile will be directly after that. Outside of that, for the node runners, the 0.18 update is going to be coming out imminently, as soon as we've got that last synchronization issue resolved. And I think that wraps up all the items. Cool, so let me go ahead and check the various chats, because I've only checked Twitch and Twitter, and see if there's anything on Telegram. Oh, this actually wasn't a question that was asked just now, but I do want to answer it anyway, because I know that there's other people that are watching this right now that have this question. For those who are not seeing a seniority score yet on the nodes, they're wondering if it's a fixable issue. Yes. That will be resolved with the 2.10.18 update rollout. Like when it rolls out to everyone, the final migration step of it will fix the seniority display issue. Let's see, is there anything else? All right, checking Discord. And Telegram's clear, Discord's clear. Let me go back to Twitch and Twitter. If there's any questions that anybody has left, I'm happy to answer them. Oh, yeah, actually, I'm sorry. I guess I didn't really describe that in detail. So they asked, can you re-explain what Hypersnap is? So right now, if you visit the Hypersnap page, it just kind of talks about the features of it rather than the full integration controls. But if you're familiar with what we've been building with Q, one of the core principles is that everything is private. Everything's private. And the cost of having privacy as that component means that it costs more slightly for compute at a bare minimum. It has its own, own foot guns, potentially its own problems that you have to solve to utilize those features. And one of the things that was the genesis of Quorum in the first place was creating a decentralized version of Discord, which we've done through Quorum. But over time, Quorum's kind of evolved into this super app kind of situation. And so we've worked with obviously anybody who's known me long enough, I've worked with the Farcaster team for a long time. And through that, we created a new version of the network, which is the Snapchain protocol. And that is a public social network. And so when you think about Twitter, if you think about Mastodon or Blue Sky, Snapchain or Farcaster in the more general term, that's a decentralized version of at least Twitter. Some would argue AT-Proto is decentralized, but when you really look under the covers, it's not. I know shots fired, but it really isn't. Everything's dependent on Blue Sky, so at that point, is it really decentralized? But Q, as in Q Inc., we run a Snapchain node. We are actively involved in the features of Snapchain. We've presented PRs to enhance. One of those is to integrate QNS as one of the potential name options because they already support things like ENS domains. But we take this a step further. There's a lot of features that, when you're building something like Quorum, for example, that integrates with the Farcaster ecosystem, there's a lot of things that aren't on Snapchain itself. And so we have created basically a hyperdimensional Snapchain, if you will, called HyperSnap. And what that does is it layers on additional APIs that are valuable for people who are building clients, whether you're building Quorum Mobile as a fellow contributor to the code base, or if you're building another Farcaster client. What HyperSnap enables you to do, though, is it also lets you plug into all of the other features of QConsole. So when we're talking about, as I said earlier, setting up an ED25519 signer key for a user, you can actually plug that in as part of your logic to be an MPC-driven key. So if there's any rules you want to have around it, if you want to have a group shared account on a Farcaster, there's not really a way to do that natively. But with the use of QKMS and HyperSnap, there is. And so it's just part of that broader value add. One of the things I mentioned at the very beginning, the ways in which we do things, it's either in service of the protocol itself, in service of other protocols, or in service of the broader web. And all of those things either enhance the security posture, the performance, or the cost of doing anything in those particular domains. Let me check real quick. Cool. Oh, I guess one other thing I should mention real quick with HyperSnap. It's not just plugged into these services on QConsole, it's plugged into Q. And so the way in which blocks are produced on Snapchain and the way in which blocks are produced on HyperSnap specifically, because it has that hyper layer block that just envelopes the original Snapchain block and adds additional information, that is an alt fee basis app shard. So as we roll out updates to HyperSnap, the next one that's coming out will actually be a really good cookie cutter template for anyone wanting to build alt fee basis app shards on Quorum. Subsequently, after HyperSnap, you will also find our bidirectional bridge. That too is an alt fee basis app shard, but the way that it works isn't actually for the bridge itself, it's for Ethereum. We basically will be converting Ethereum into an L2 that plugs into Q through the use of the alt fee basis app shards. But that's basically how we do things. If you create that alt fee basis app shard, you are creating these BLS 48581 or KZG specifically proofs that allow you to address any of that content, or conversely address any content in the rest of Q and prove bidirectionally for anything that you need to prove. In the case of a bridge, that's pretty important because you need to prove that the funds are bridgeable either onto Ethereum or back from Ethereum. And so that, again, all of those things enhance the potential security of another protocol. For example, with Ethereum, by having that core primitive, you're able to create a anonymous bridge that allows for tokens to be securely exchanged in a private format that does not reveal the owners. Or alternatively, you're providing at least the ability for users to do any sort of bridging operations across other networks. And I think that about covers it. If I can find any other questions real quick, otherwise we'll be closing out for the night. Oh, huh, weird. Okay, those didn't pop up until just now, but let's see. Quorum and QPing. Oh yeah, sorry about that. So the way that I was talking about the relationship between the two, the way that QPing works and QQ works is under the hood, these are using the dispatch mechanism. So the dispatch mechanism of Equilibrium is effectively a hub and spoke queuing and notification model. And so what I'm providing in terms of these APIs is literally how Quorum works under the hood. So it's just an easier way to do those same things, but with a more familiar API. And provided the billing tests out, there will be non-free tier usage. So yeah, like I was saying, this is using an all-fee basis app shard at the moment. So technically, no, you can do the non-free tiers now. But how that works depends on which way you're paying. So if you're paying with a credit card, you can set it up through Stripe, or if you're paying with cryptocurrency, it's a credit-based model. You know, as you use your payment, you're deducting those amounts until the overall quantity has been consumed, which is why you can see I had a $10 credit that I manually triggered plus two very small USDC transactions on base and burned through them all pretty quickly. Last thing, okay. How do we distribute key shares across other contributor wallets, or do the contributor wallets participate in the generation? It's the latter. And that's one of the very critical things about how real MPC has to work. Because if you're having a trusted, like this, in MPC parlance, this is called a trusted dealer model. But when you have a trusted dealer and you're wanting to move to a, something that is potentially equally adversarial, like you want to make sure that the collusion factor required is that threshold. You cannot have key generation happen on one machine. You cannot have a trusted dealer. And so the key generation algorithms that we use for distributed key generation are essentially maliciously secure. And so in other words, when you're doing DKLS 18, it's kind of pointless because it's just the ECDH assumption because you've got two parties, 2 of 2. But when you're doing a threshold like T of N, then whatever your threshold is your collusion risk. And the way that happens, and I've talked about this on a lot of historical streams, so I'm not going to like spurg out on Excalidraw right now. But the way that it works is essentially constructing the Lagrange polynomial and then distributing those, like each party is constructing their own Lagrange polynomial. They add them together individually as points that they've evaluated based on each party, distributed the points, created the outcome, and then you end up with the full multi-party key generation where no individual party that has been involved in that key generation process has ever seen any key material besides their key shard. I don't know if that's fully what you're asking, but if it's not, the other thing I can think of that might be a question that's kind of related is how you do resharing of keys. So like one of the things that happens in some signing algorithms is that when you perform that particular signature, you are essentially emitting some degree of entropy that potentially, depending on the algorithm, could over time reveal key shares between the individual parties. And so what a lot of these algorithms also have is called a key refresh. But key refresh is actually kind of cool for another reason. So like you were saying, do all parties have to be present? Technically not in the long run. So if you had like let's say you had a quorum of 7 of 8, and you wanted to expand that out to, a quorum of 7 of 15. Technically, you're reducing the overall percentage of people who have to be present, but at the bare minimum, you're keeping the same threshold you originally had. In that scenario, when you're doing a key refresh, the other parties do have to be present for the refresh, but they did not have to be present for the original key generation. Okay. Cool. Well, I will go ahead and wrap it up from here. Okay. So, thanks everybody for attending. Next time, it should just be a regular Sunday stream, roughly the same time. I don't think that we're going to move too far from that, but we should actually keep the cadence this time around. It's been a hell of a couple weeks. Cool. So from here, if you have any other questions, by all means, reach out to me on Twitter, Telegram, I don't think you can on Twitch outside of the stream. Discord, or of course Quorum. I generally have the same username almost everywhere I go, but it's either going to be Cass Equilibrium or Cass on Mars. All right, everybody. I will catch you all in the next session.